Hey everyone, and welcome to this calculus lesson. In this video, we're going to start learning how to actually use implicit differentiation to find some tangent lines and to find second derivatives. So if you haven't seen the last two videos, make sure you go and see those first so you understand what we're doing here. And then now, let's get started. So I do want to make a note that before you really start doing any of these problems, that you probably should get a calculator for a couple of them. What we're going to do is we're going to find what values of x will the curve have a horizontal tangent. So with the horizontal tangent, remember you want dy dx to equal 0. And we're going to show our work and explain our thinking. So I'm going to start by taking the derivative here. So that I'm going to get 3x squared plus 3y squared dy dx equals, and I'm going to use the power rule here. The derivative of the first, which is 4, times the second, plus the first times the derivative of the second, which is 1 dy dx, and then the derivative of 1 is 0. So what values of x will this curve have this? So again, we want to solve for dy dx. So let's bring all of those to one side. So 3y squared dy dx minus 4x dy dx equals 4y minus 3x squared. And then what I want to do here is factor that out. So dy dx gets factored out, and I have 3y squared minus 4x equals 4y minus 3x squared. And then solving for dy dx is going to get us 4y minus 3x squared on 3y squared minus 4x. Okay, just dividing that out. And so what I want to do is say, okay, where does this have a horizontal tangent? So I'm going to set this entire thing equal to 0, which is really just setting that numerator equal to 0. So I'm going to take some space here. I'm going to set that numerator 4y minus 3x squared equal to 0. All right, and what I'm going to do is I'm going to solve for y. So 4y equals 3x squared, and then so y is going to be 3/4 x squared, something like that, or 3x squared over 4. And now I'm going to take this because we want to find what values of x will this happen for. So I'm going to take this, I'm going to substitute this back into that original equation above. All right, so I'm going to get x cubed plus y cubed, but y we just found is 3/4 x squared. So 3/4 x squared, and that's going to get cubed equals 4x times 3/4 x squared plus 1. So let's pause and just talk about why we're doing this, okay? So we know that this is where dy dx, where the slope is going to have, is going to be equal to 0, because that's a horizontal tangent. So what we're doing was we ended up solving for y, and now we're just taking that value for y and we're substituting it back in to that original equation to solve for x, okay? And that's going to give us those x values. So what I'm going to do now is I'm going to essentially just set this equal to 0. So x cubed plus 27 over 64x to the 6th equals, those 4's are going to divide out, so I'm going to get 3x cubed plus 1. Okay, subtract those. So then 27 over 64x to the 6th minus 2x to the 3rd minus 1 equals 0. Okay, and this is where your calculator is going to come into play, because what I want you guys to do is just graph that, solve for x there using a calculator so that you can get these approximate values. X is going to be approximately negative 0.770. Okay, again, always going to at least 3 decimal places. 4 is preferable. And then we also got another x value, okay? Again, remember that implicit functions are not explicit functions. They don't have to follow that vertical line test, okay? So we can get multiple x values here where the y value is doing a particular thing, okay? When in this case, it's going to have a horizontal tangent. So x is going to be approximately, let me fix that, approximately 1.732. And that's going to figure out what values of x will this function have a horizontal tangent. So now we want to take that same function and we want to say, okay, where will it have a vertical tangent? And what you want to remember for vertical tangents is that's going to be where dy dx is undefined. All right, so when it's undefined, that's where that denominator is going to be equal to 0. So let's take this 3y squared minus 4x. So we just did that work up above, and we're just going to take that denominator because that's where you're going to get values that are undefined. Okay, we're going to set this equal to 0, and remember, we just want to leave it in terms of y. We're not solving for a specific value. So we're setting that equal to 0, and we're going to solve here, and we're going to get x. So then I'm going to get negative 4x equals negative 3y squared, and then x equals 3/4 y squared. So in terms of y, if we had values of x or y that we wanted to work with, we'd be able to find exactly those points where we had a vertical tangent. And now down here, we've got a couple more problems. So given the curve y squared plus 2y equals 2x plus 1, we want to find the second derivative. So we've got the second derivative here, and that's all that means, the second derivative. So we're going to go through this the exact same way, and you're going to notice how things pop up in a nice little pattern. Kind of like in this mode, a lot of things happen in a very particular pattern, but you got to have your basic foundation rules on lock. So I'm going to take this derivative, so I'm going to get 2y dy dx plus 2 dy dx equals 2 plus 0. Fantastic. Okay, so let's see. Dy dx, 2y plus 2 equals 2, and then dy dx equals 2 over 2y plus 2. And I know that everything can be divided out by 2, so I'll get 1 over y plus 1. And so as I'm doing this, I'm also going to think about, okay, I want to take the second derivative. So I'm going to take this derivative, so I'm going to write this as y plus 1 to the negative first power. So the reason I'm doing that is because I want to take that derivative again. So then when I take the derivative of dy dx, I'm going to get d2y dx squared equals, and then I'm going to take this derivative right here because it's really nice to work with. So that negative 1 goes down, negative 1, and then the y plus 1 stays. Subtract 1 from the exponent, so negative 2, and then derivative of the inside, which is just 1 dy dx, so times dy dx. Well, you might be thinking like, wait, I have a second derivative and first derivative there. What am I going to do with that? Well, we know what dy dx is. We know that's 1 over y plus 1. All right, so let's take this, the second derivative over dx squared equals, all right, so I'm just going to rewrite this, negative 1 over y plus 1 to the second power in the denominator times 1 over y plus 1. And what I can do here is I can just multiply those out so that the second derivative equals negative 1 over y plus 1 to the third power. So you just end up making that substitution again in the end. Now that we have that very nice answer, we're going to come over here and we're going to do it again, okay? Just find that same pattern, finding the second derivative. So let's go ahead and start this. So we're going to get 2x plus 2y dy dx equals 0. All right, solving for dy dx. So I'm going to get 2y dy dx equals negative 2x, which gets us dy dx equals, the 2's are going to divide out, so negative x over y. All right, so when I do that second derivative there, I have negative x over y, which means I have a quotient happening. I'm going to have to use that quotient rule. So let's see what we can do here. So dy dx equals low d highs, so that's negative x, so that's going to be times negative 1. All right, minus highs, so then plus x, d lows, so then that's going to be dy dx, and then square the bottom. And again, just like we had happening last time, we have another dy dx that we're going to just have to substitute with, okay? So I want to get dy dx equals negative y plus x and make my substitution here. So I'm going to get negative x on y over y squared. We want to really just clean this up a little bit, okay? So then, let me see what I can do here. That's going to get me, okay, so I want to have one fraction in my numerator, so that's going to get me, this is over y, so I'm going to multiply this by y over y, and I'm going to get negative y squared over y. Let's see, where did I get that negative x from? Oh, okay, so that goes back to be negative. So minus x squared over y over y squared. All right, so then really over that y squared, I'm just going to multiply that by the reciprocal, so times 1 over y squared. That's what I'm going to do with that. And since that they're both over y, that's going to be over y cubed. Okay, so one thing that I notice here before I move on is that those are both negative. So I can factor out essentially that negative sign, and then it becomes positive in the numerator. Makes it a little bit cleaner. So I'm going to factor out that negative. Oh wait, this is second derivative. I already screwed up here. These are all should be second derivative. All right, so I've got the negative in front of it here. And so now in my numerator, I have y squared plus x squared because I factored out that negative. So y squared plus x squared. Now in my denominator, I have y times y squared, which is going to be y cubed. And that right there, again, a very clean final answer. And that's what you want to get to, is things that are going to be like, they're not going to be too complicated. You're going to get a feel for when these problems are going to stop. Yes, it might look really complicated as you go down, but at the end, you're like, okay, this is something I could work with easily. This is something I could work with pretty easily, okay? So keep that in mind as you're moving forward. All of these things should have a pretty finessed end at the final answer, okay? Again, you're solving problems that have already been created to look for solutions, okay? Now, of course, if any of these things did not make sense, please reach out to me and stay with us in that next video as we go over an AP Calculus free response question, and you're going to start to see those a lot more moving forward. If you do have any questions, reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.